request panel members to be please come on the dais. And I request to just have some kind of a discussion regarding whatever the ancient knowledge we have. So from this, what strategy we should adopt for the future of metallurgy, and how we can excel in this particular field in our country. So I think anyone from you, please start with.
If you permit, then I'll begin with 1 or 2 minutes. Now, I was learning from the past as far as iron metallurgy is concerned in India and future. Having spent 12 years or about 12 years with the steel company, and today I'm using the steel in the automotive. So where do you go actually? Can we use any of our ancient knowledge in these areas when we are talking of 122 million tons that India produces, or 5 million cars which you produce? Can we use some of our old knowledge? If I put myself in that position, I don't think the trajectory is very much visible. It's not very clear. However, there are a few things. One of them is, of course, the Damascus part or the high carbon material, where a lot of interesting things can happen, from divorce eutectic transformation to divorce eutectic transformation with associated deformation. Those are all academic kind of thing. But if I'm talking of the still in the future, and from 122 million tons, you want to go to much higher level of 330 million tons, two things come to my mind. One is, where are the ores? As Professor Ballal said, the magnetite part is on the western part of India. The eastern part, which is currently the capital of steel making, this is hematitic. So here in this area, the ore itself or mining itself is going to be a big challenge. So raw material challenge. So today, people may not know here that when you do the mechanized mining, huge amount of fines are produced. And plus all steel plants, when they wash the ore, then slimes are there. These are super fines. Using those in the steel making has been a challenge. So these are actual steel making challenges. We know what to do with that. Alumina is higher. Interestingly, in Indian bauxite, we have iron, and in the Indian iron ore, we have alumina. So we have problems if the alumina goes up, the blast furnace productivity comes down. This is all well known. So therefore, what all the new modern steel plants, including Jindal's and the Nippon Steel, ArcelorMittal, there's a new company, all these, whatever they are doing is collecting all these fines through slurry transportation. So slurry transportation is no more a technology which is in the laboratory. No, we have about more than 600 kilometers of slurry transportations of the fines. So fines, we just heard from the lecture. I didn't know from the lecture of Professor Ballal that there are villages or people who are using fine ores and making or trying to make, but they're using, unfortunately, magnetite, so they have problems in reduction.
They don't know about they make excellent, the best steels.
Best steels. So therefore, here is an example. This is the first example I find where from the powders also, that means very fine ores. So fine ore utilization in India was not happening 10 years back. Today it has become a must, number one. Number two, extremely iron ores, government we have stopped. So it is not 55% plus, so you have to use 50% and so on. So that's also a bigger challenge. So beneficiation and the instruments, etc. for that. So here we don't have the ancient thing, but we can learn actually from the low carbon and high carbon ancient metallurgical process.
Yeah. So please, Professor Ballal, please share your views.
Yeah. See, technology is very specific to region as well as time, because as against science. So transporting some 2000 years old technology to modern times is foolish. It doesn't work. You know, you can't make wood steel now because there are alloy steels which have tremendous properties. Why would you break your head on making woods? But what is transportable is the knowledge of understanding behind underlying science. Why did use wood steel get the property it does? That is a question worth exploring. Not to reproduce woods. What is important is the science behind our technology over the years, because the knowledge is what is transportable. The understanding part of the knowledge, not the technique, but the technology behind the technique is what is transferred to. So we need to do a lot of PhD kind of work rather than MTech kind of work, on trying to understand.
Addition to what Professor Badal has rightly said, for example, superplasticity, which with so much of care and research we are doing, we believe that ultra high carbon UHC material, which Vinod is using also here, is a superplastic material. As Sarvi said, the Damascus source revisited the question mark, but that introduces superplasticity. So with the high carbon material, normally we think that this is brittle and strength is high. But no, we can also make it highly ductile, as we will show also. In NML, we recreated that. Thank you.
That is what is important. And, going into the future, as you say that it is a knowledge economy that is becoming important. So our emphasis on building up scientific knowledge is very, very important because that is where the present day is that of science. So we can't go back in time.
Right. I think that is not important.
Let's not keep on glorifying our past and stay in the past. That is for old, tired people like me. Young people like this should look forward.
Right.
I just want to make only one point with respect to the phosphorus. All of us know that it is giving cold sharpness and then it should be removed. But can we adjust? Okay, can we adjust the process parameters so that we retain phosphorus and make a more a relatively cheaper melting and consolidation process, but effectively utilizing the process in a more microstructural control manner through the thermomechanical processing. So if we do that, I feel at least we get one benefit of the doing all these studies and realizing that phosphorus has very good role in corrosion resistance. Thank you.
Yeah, I forgot this point. Most of the time, our problem must be modern post-independence technology has been that we import technology from Europe or Japan. As I told, they are location specific, they are culture specific. Like this phosphorus problem. Phosphorus is good in the tropics, but it's not good in cold countries because it increases DBTT. So they have driven see the Howrah Bridge, which is standing so well. What is it, phosphorus? 0.6. Now we say 0.15 is too high. Why? Because when they laid this Siberian oil line, they were breaking because it is minus 20, minus 30 degrees. DBTT crossed, it was cracking because of high phosphorus. So they have drowned it too. So we have to make steel which is for the tropics. We can't get it from alumina. Problem is the same problem. Nobody else has got. If you improve blast furnace technology from Europe.
The only issue there, this is very important. Only issue is Indian steel is not used only in India. In India, we are using actually a lot of imported steels. And our steel also has to go abroad. So therefore, the previous kind of economy in which we are operating was a kind of different kind of economy today. Today, our automotives, our steel and our bearings, it has to go around the globe also. Make in India, but they are meant for the whole world also. So which is why this business of, but how to tackle phosphorus, we know exactly. 3D atom probe we use and you put niobium or boron so that grain boundaries you fill up and phosphorus you drive out of grain boundaries. That's a physical metallurgy. Thank you.
Yeah.
I think what the panel members have said. In addition to that, I think a lot of research needs to be done in mixing metals, in alloying metals to produce new alloys which are lighter and tougher. Also, the bonding of various materials, which will give you lighter materials and tougher materials, and the materials that stand the extreme temperatures.
Madam Mr. I just want to add here, the new steels in the past 20 years, I think Murugan was here. 3 days back, we had a 2-day conference, international conference, only on the global conference. So all of you would like to know that the ultralight steel auto body program, in which 33 steel companies in the world combined, and we were the only one from Tata Steel then. So ALSAP, which is there on the net, you'll find, hyphen AVC, Advanced Vehicle Concept. So therefore, Trip Steel Prip Steel, BH Steel, the Queen's Protestant Steels, all these are being produced in India. So it's not as if the knowledge is only one side. So practically we know exactly what is the high strength steel. These are called ultra high strength steel. So high strength and toughness, as Professor Ballal also said, combination of that, which is being used in our automobiles today. So the automobile body has come down, car weight has come down with ultra light steel auto body program. This is a global guide.
But there is no end to this race. Future will demand still better materials, and the research has to go on to meet the needs of the future. What is there today, tomorrow will need even better.
Right. Right.
Yeah.
Yeah.
So I have already covered my point.
Yeah.
And one thing, based on the discussion, what I think, we should somehow suggest Ministry of Steel to have a kind of PhD. Ministry should support PhD programs so that local technologies should be developed, and we should also target few ancient, good quality, you can say, materials, which will be useful for different applications.
And also for the education, like the education system.
Correct, correct.
The awareness of.
Yes, yes,
Yeah.
yes, yes.
Yeah.
Yeah. We cannot replace steel. This is the fact. So we have to live with steel, and we have to work for it.
No, since you raised the education, I have a strong criticism with respect to all IITs and NITs. Unfortunately, they have moved away from metallurgical engineering to metallurgy and material science. This is very, very unfortunate. Let me put it bluntly. This should not have been allowed by the powers that be or whoever it may be. This is a wrong strategic mistake we have done. I am sorry for that.
No, you are right, sir. You are right. No need to say sorry. It is the real fact.
I have 2 points. One is related to this Agaria technique. In fact, that is part of my presentation or panel discussion tomorrow. What I have in my mind is that the ladies or even the gents, family-wise, they are working on it. Whether the fines which are available at mine site, which he had just now said, whether they can be used by them and make pellets out of it and use a kind of portable small furnace which they can produce small quantities of steel. There is a buyer for it who, like a mini steel plant, where they take these ingots and then pay them some price, so that this steel is used in their bigger furnaces. Okay, so this helps in Ministry of Culture and Social Welfare. Also, it helps them that you don't relocate the agarias, because many of their families might have left the profession and might be going for software industries. I mean, I'm just quote in unquote. But if you want to retain their cultural heritage and also economically you want to bring them up, this is one solution which I have. So maybe that can be considered by.
Started doing that for some of the process bronzes in Odisha, and the pellets which are produced today, all glass furnaces we use, of course, we are using pellets, we are using sinter and stone. But he is telling the pellets could also be made available to the
Yes.
Yes, Adivasi.
Yeah,
So that
Adivasi.
it becomes easier for them to process.
Yeah.
You can sustain it. It's an interesting possibility.
Yeah.
I just respond.
Yeah.
My colleague, Professor Buddhe, Gandhi Institute at Benares, he was working on that. That's how I could go. Otherwise it's very difficult to get into a tribal area. I had a nice anecdote, but this is not the time. So he called an Agaria Panchayat. The very last area, some 3,000-4,000 area. They had a 3-4 day panchayat to discuss about their problem. When they were asked what is their priority, government intervention, they said first is education for them. Their children should get out of this profession. Second is agriculture. Then they said third one is, yes, we want to maintain it because it's a religion for us. See, the Lohasur is whom they worship. So they continued their furnace working for some time, basically because low hustle comes to their house. Otherwise, they have no interest. It's a back-breaking work with very low, and it's based on charcoal and not on coal. And the charcoal, they are not allowed. See, we could only find Agaria existing in places where the truck would not go. When the truck goes, all these things go to the timber lobby and not to Agaria. Agaria will not be allowed to come.
So
Yeah, that kind of.
here, connected with this actually is you can think of this. If you go to the net today and find out ancient iron making, how many YouTube things are there. I was teaching it also both in Kharagpur as well as in Mysore. You find at least 5 to 6 YouTube fantastic kind of processes. They have rebuilt in Burkina Faso, for example. So Burkina Faso thing you will find, and you will find also in Western Africa, Eastern Africa also, YouTubes. How many YouTubes are there? We should have given actually a lot of facility to Professor Balan. So excellent YouTubes on Agadia and making, even in NML, I feel very sad now. And we did not make those YouTubes those days. But today it is necessary to preserve the technology so that it is in animated form.
Yeah.
Yeah. Yeah.
I think in MP that Museum of Man or something.
Yes. No,
Bhopal. Yeah, Professor Bhanuprakash, late Professor Bhanuprakash from our institute had gone to Agarias and he also made, and there are some video recordings that he made and he has submitted to IAM, if I remember correctly.
Internationally, today, if somebody in US wants to know how the Indian ancient iron making process is, he will get a lot of information from Europeans and from Africans. And the African thing is made by the Europeans, but we don't have many.
Yeah, no, but what we are discussing here is how to carry it forward, if we can carry it forward, the old technology. Yeah, my second point is already mentioned by Dr. Jaikumar, that is, why not reverse this process to some extent? Instead of removing phosphorus and re-entering, can't we learn from that and directly produce without removing phosphorus? I mean, steel experts are here.
All electrical steels, we have a lot of phosphorus deliberately because of punchability and because of magnetic aging resistance. So those are instances where high phosphorus is there.
That is because Westerns are using.
Properties.
No, we have to go in raw. We have to go in our own. Can we get into high phosphorus reinforcement?
So reinforcement, we have done the TMT device for buildings. We have now a grade where phosphorus is high, but not at the green boundaries. But if you don't ensure that, then there will be disaster.